So this is getting us into these advantages of randomized experiments. So just a little more terminology, just so we know what's going on here. So this isn't necessarily stuff we'll be tested on, but just to kind of explain what's happening. So placebos, they're a big part of randomized studies. So when studying the effects of treatments, we often create a group that does not receive a treatment, which we call the control group. So when we're saying this group doesn't receive a treatment, it doesn't mean they don't get anything. It's just they are not receiving the treatment. So I had mentioned earlier, I think it was the statin drug, that we had some people stay on their old drug, and then we gave another group the new drug. So that group that's on the old drug, that would be a control group because they didn't change. Everything's the same for them. It's just the other group, the treatment group, is the one that gets the treatment. So I'll put that in here, treatment group. So treatment groups receive treatment. So just to put that out there. So sometimes what it is a control group, just it gets absolutely nothing as well. So if you had people, you wanted to see if this medication you had or a shampoo might improve hair growth, it's quite likely that you're going to have people who are not taking a medicated shampoo for hair growth. So if they join the study, like when it's looking at things like cholesterol, it's probable that the people who are going to get into your study to control their cholesterol are already on a cholesterol medication. Therefore, your control group would be on a cholesterol medication already. If you have something, like I said, hair loss, so medicated shampoo for hair loss, a lot of people are not medicating their hair loss because it's not a health concern, it's just a cosmetic concern. So in cases like that, you're likely to have people come in to the study who are not having some sort of medication. So what you would end up doing is you'd give one group shampoo and the other group would not get shampoo. So this causes what we call it's a placebo effect. What will happen is that actually the people who are getting treated and being given a shampoo might report more hair growth, even if it's not really there, because there's like psychological effects from being treated. They'll look in the mirror and they're like, they just want there to be that hair growth, and they're going to see it because they were given treatment. So as a way to counter this, we have what we call placebo, which is a fake treatment. So a placebo is a fake treatment given to members of the control group. So then the members of the control group will think they're being treated as well. The reason for the fake treatment is to control that placebo effect. Now, as I said, the placebo effect is a psychological effect caused by receiving a treatment. Individuals who receive treatments often report perceived changes that are not really there. This happens a lot with like pain medication. There's a lot of studies where they've given people pain medication and they've given people a sugar pill, a fake medication that's pain medication. And the people who are not even getting medicated for the pain will say that the pain got better simply because they were treated. So the reason we give this placebo is what we're going to have is people who are being treated are going to have a placebo effect. And if we don't give the other group anything, there's going to be a bigger difference between what they're perceiving is happening to them. So to even out that perception of treatments, we give one group a placebo and we give the other group a fake treatment. So then they both think, oh, I'm being treated. So those placebo effects are even across the board. So that is the whole reason of placebo, is just to even out the effect. We're giving it to everybody, so then it doesn't cause problems in our study. So why randomization? In a perfect study, treatment groups would not differ from each other in any important way, except that they receive a different treatment. So that's why we use that placebo, because we want to make sure that those two groups are the same. They both are having placebo effects. They're both having effects of thinking they were treated. So we want to make sure that both of our treatment and our control group are basically as even as possible. Everything between them is the same. In practice, it is impossible to construct a treatment groups that are exactly alike, but randomization does the next best thing. In a randomized experiment, Small differences between treatment groups are likely to be due only to chance. So if we test somebody, let's say, like I said, with a new statin drug, and you have your people on your old medication and the people on the new medication, we will see a perceived difference, but some of that, a very small difference, is just going to be likely due to chance. So basically, it's saying that we'll have small differences, their chance being that nothing happened. Large differences, because we controlled all these extra variables out there, large differences in outcomes among the treatment groups. If there are large differences, we can conclude that the differences are due to the treatment. So like I said, randomization tries to make two groups that are so ideally that they're going to be so alike due to the randomization that when there is a difference, we're pretty sure it's caused by the treatment solely. So it goes back to that simple random samples. We do that to get groups that are representative of the population. We use randomization in making control groups and treatment groups because we should get groups that look like each other as well. So a company identifies 2,000 adults who have high cholesterol. The adults with the highest levels of cholesterol are given a new medication that is believed to reduce cholesterol in the bloodstream. The other half have been told to take their old cholesterol medication. That's a common thing. After 3 months, those on the new medication saw a significant decrease in cholesterol in their bloodstream. Once you identify your controlling treatment groups, and then tell me, was there actually a placebo given? So you might have to read back over that again. And then decide, is it reasonable to conclude that the differences in cholesterol was actually due to the new medication? So we might be nitpicking a little bit with this. So my control group would be the people who are on their old medication. So people on their old medications, that's my control group. They did not change. So that was half the population. Then we said the other half of the populations were given the new medication. So that would be the treatment group. They are getting the treatment. The other group is not. So we do have a control group and a treatment group, and we want to know, was there actually a placebo given? So this can be kind of really technical here. So if you reread this again, adults with the highest level of cholesterol are given the new medication that is believed to reduce cholesterol in the bloodstream. The other half have been told to take their old cholesterol medication. So they've been told to take their old medicine. So they are getting a treatment, but it's not really a placebo because in this case, they know they didn't get the new drug. So the idea of the placebo effect is that if we give them a treatment, they're going to perceive a difference. These people will not be perceiving any differences. However, the other people on the new medication may know they're on new medication or they have been given a new medication. So if we tell them what they're having, there is no placebo. So is it reasonable to conclude that the differences in cholesterol is actually due to the medication? I would say no, because one, we don't have no real placebo because we told them what they were taking. So the placebo is not actually acting as one. The other part of this, there was actually no randomization. If we go back, the adults with the highest levels of cholesterol are given the new medication. So we have no real placebo, no randomized treatment. I would say it is not reasonable. It's not reasonable to conclude the medication is making a difference. I wouldn't discount. I mean, it could possibly do it, but we couldn't, in good conscience, with these problems in the study, like I said, the lack of randomization and the no real placebo. If we don't have either of those, a placebo and a randomized treatment, it's possible that the lowering of the cholesterol is not actually due to the medication. There could be something else that is causing it. For one thing, if you have adults with higher cholesterol and they know they have higher cholesterol, they may be making more being more active in trying to lower that cholesterol. So we have a problem that we're not randomized. We have two groups that are not similar. And because they're not similar, they are going to introduce other problems into the study. Like I said, the people with higher cholesterol levels probably know their higher cholesterol levels and maybe eating better or exercising more because they're trying to get those levels down. Or if you have people who are like, kind of like, my cholesterol is a little high, may not be making any effort at all to lower that cholesterol. And so you would not be seeing it. So the medication could be absolutely doing nothing in its lifestyle changes that they're making because they're two different groups. Now, if we randomized it and some of those people with the high cholesterol were in both groups, and some of those people with the other cholesterol levels were in both groups, then that's randomized. Those two groups will look like each other. So the only thing that should be different in that case would just be the treatment. Scientists report the studies of reported the results of a study to determine whether a new drug called, I'm pretty sure this is a real drug and I can't say it, Reltiger, whatever, that one starts with an R. The R drug determined whether a new drug called R is effective in reducing levels of virus in patients with HIV. These patients were divided into two groups, where one group was given our drug and the other group was given a placebo. In the our drug group, 62% of the subjects had reduced levels of virus, where only 35% of the placebo group did. So once again, it's a placebo because they're given a placebo that accounts for that 35% decrease, but we don't know that. Is it reasonable to conclude the differences is actually due to the drug? So, one, we have a placebo. And there's no mention that people know what they were given a placebo. Like in the other case, they were told to keep their medicine. They knew they weren't treated. So we have a placebo. That's good. Patients were divided into two groups. The only problem here is it doesn't say they were randomly divided into two groups, but it also doesn't specify that they were, split up like they were before, where we, like took people with higher levels of virus and put them in one group and lower level in the other group. We just divide it in two groups. So we're going to assume there was randomization here because it's not specifying that they were doing it by any other means. So randomized groups. So those randomized groups would end up looking the same. So we have two groups that should be acting the same. They should have randomized the people into each group. They're both given with this, a treatment of some sort that they physically see. So we got randomized assignment of treatment. And a placebo is given. So placebo effect is controlled. I'm assuming that these differences I'm seeing are probably caused by the drug. So we can reasonably conclude the drug has effect. has an effect on virus levels. So we're not laying out some sort of system of how we're like assigning patients to groups. It's kind of just assume that it's going to be randomized in that case.